All right, so down to the last part of this, which is power. I said power was going to come back, and that is we talked about it with type 1 and type 2s, right? This is actually directly related to a type 2, but this formally, right? So this is a probability that the test, right? And when we say test, we're talking about the significance test. Will find convincing evidence for HA when a specific alternative uh, is true. Okay, so kind of to abbreviate that there, basically the power is the probability that the test does what it's supposed to do, and you reject HO when you are supposed to reject HO. Basically, the probability of doing the right thing. And the power can only be calculated for a specific alternative. I can't just find power and say, oh, there's the whole power for this entire test. It would have to be if some alternative is true. All right, so I'll show you an example in a second. But if you remember our chart, if you go back, you had the whole type 2 thing, but the power is equal to 1 minus the probability of a type 2 error, right? And obviously 1 minus the power is the probability of a type 2. All right, so yeah, that's power, and then we can say that the probability of a type 2, right, equals 1 minus whatever the power is, okay? So that's how those two are related. And like I said, you have an example that's printed. It's actually number 5 on that paper, right? So we'll move this down, and all right. So here's your null, your alternative. You have your P that's defined, and it's saying the new vitamin tablet is expensive to produce. The researchers would like to be convinced that it really does reduce the risk of ADHD. Power of the test to detect a P of 0.05 is 937. So interpret that value. Okay, so what they're saying here is basically if, right, so I would say if the actual, right, or the true proportion, if the true or the actual proportion of children who would develop ADHD with the tablet, right, if that actual proportion is 0.05, right, because remember, we're assuming that it's 0.11. So if it's in fact 0.05, obviously this is going to be wrong, right? Your null is going to be wrong. So what's the probability? And that would be the 0.937. We would say that there is a 0.937 probability that the company finds convincing evidence. Right, for P is less than 0.11. Okay, so again, in other words, I had to pick a specific alternative. Now, that's not going to be 0.937 if, say this P that was chosen was 0.07, right, or 0.1 or 0.09, they're going to have different powers. So the power for it to detect, right, basically for the test to kind of say, hey, it's definitely not this, because we know it's this, that would be a 93.7%, which is actually really high. Anything over 80% power is usually pretty good. It's like 80% power is like your 95% confidence and your 5% significance. All right, so that's what the power is saying, I guess, in that example. Okay, so I also have for you a way to take a look at this as well from like a visual standpoint, right? Which, if you look here, all right, so this is what we're assuming to be true, right? This is just for example here. So we're assuming that this is true, that the mean is in fact 30, right? This is our null. And I'm going to do a right-sided test, right? The HA is something, I'm trying to show the mean is greater than 30. And the sigma was 3, n is 50, right? Again, those are just kind of arbitrary values. And then I'm going to have an alpha of 0.05. Now, say this was in fact false. This is false, okay? But I don't know that because I don't know that I'm picking from a false, I think I'm picking from this distribution here, okay? But in fact, say I'm picking from this distribution instead. So here's where that whole type 2 comes into play with this. When you are looking at the areas, right, that yellow area, that is the type 1 error. That's where you're going to end up with a type 1 because you would be rejecting HO when in fact HO is true. Okay, and then the red part right here, that's actually your power. All right, so let me kind of write this out for you. Whoops. Okay, so this right here, this would be the power in the red. All of the area over here, that would be all of your type 2. Okay, because here's the distribution. Like I said, you think you're picking from something in this one up here, right? You think this is true. You think this is true, right? And this one is the hypothetical true. Like, what if this is true, right? So whatever x bar you're going to get would be from here. Well, this would be rejected off of this because these are all of the values that would be rejected of what you would think. Where in fact, if you get any of these values, that's actually what's getting rejected. Any of these. So this part in the red, this is your power. So if the mu was 31, that power would be 0.762. Okay. I'm actually going to make a separate video on how to calculate all of that, but that's, I guess, kind of how that all works out, right? I'll try to maybe showing you the calculation that would help a little bit, but this is the power. This is, the what if this is true. This is what you think is true when you start the test. Okay. And then you can see that, let me change the thing here. With this, right, and I can get rid of that part. If I wanted to make this power increase it, right? If I want to increase the power, I can do a couple things, right? Let's see what we can change, right? So let's see. Let's increase the sample size, right? So instead of 50, let's make this 200. And if we update, right, there you go, power went up, right, just by changing the sample size, right? Notice how these moved. This was further. And if we made this back to 50 and update it, right, if everything held constant, and what if we went to, say, 25, right, power would go down even further. Okay, so one thing to increase power would be to obviously increase the sample size. Because if you want to increase power, if I want to make this area bigger, right? This is the area I want to make bigger. I've got to make it easier to reject, right? If I make this area bigger, if I start pulling this down, that means I get a bit more red. So how do I move this down? Well, that's my alpha level. That's what's needed to reject HO. So if I change alpha, right? So let's say instead of, right, you can even see this is actually updates it as we go. So the smaller alpha is, power is going down. The larger alpha is, the higher, the higher the power. Okay. And then the last thing we can do is change the alternative, right? So this one, it's kind of obviously the further you get. So instead of 31, that was a 0.62. Let's say this was 34. Okay. What's the probability that it's going to detect? When I say it, the significance test is going to detect that this is wrong, knowing that the alternative of 34 is in fact true, right? That's 100, that is a power of 1. So if I change this and said, all right, let's make it 32, right? The further these two numbers are apart, the null and the predicted or the chosen alternative, the higher the power also. Okay, so let's get that in kind of our notes of how to increase power, right? So if we want to increase power, we've got again, everything else is held constant, right? But we want to make a larger sample. All right, that's one way. Two, we can increase alpha, right, which is your significance level. Or the other way to increase power, the null and alternative are further apart. All right, so that's the one we can't really change too much because if it is something, we got to make sure that it is going to detect it. But again, if I want to make the larger sample size, the drawback there is more time and money. If I increase alpha, right, by increasing alpha, we know that's the probability of a type 1. So if you increase alpha, you increase the type 1 error, but you also decrease the type 2. All right, so the last example I have for you right here, right, same one as before, but determine whether each of the changes would increase or decrease the power of the test. Right, so A, you're using an alpha of 0.1 instead of 0.05. Increasing alpha, that's going to increase your power, which is going to decrease your type 2. All right, if the true proportion is 0.08 instead of 0.05. So that's actually getting closer to the null. So that's actually going to decrease power. And if you decrease power, you increase a type 2. And then using 500 instead of 200, you're increasing the sample size, which means you increase power and you would decrease the probability of a type 2. All right, so stay tuned for a bonus video with how to calculate the type 2.